I am still irritated with the fact that they didn't do this with the shortened schedule. They usually, for college fair, will take every period and take 5 minutes out of it, and we get like an extra period.
But what did we do?
You would usually then do like a career speaker day, or
Yeah.
I guess they didn't have enough speakers, I guess. That's what this is the first time they've ever done it this way, and I am irritated. I'm irritated with the choice they made. They made a choice, not a good one. It's a choice though. All right. We gonna play with circles. So write this down. You're gonna want to have this down. You're gonna want to have this written down. Please write this down. Fix that one. We playing with circles. Oh, we go play with circles all day. The whole thing. We playing with circles all across the board. Equation of a circle. X minus h quantity squared, y minus k quantity squared equals our radius squared. This h and this k give us our center. It's the h and the k. Because that's what makes it curve. If it's not squared, it's a line. So the squaring has to happen, and the x squared gives us the top curve, and the y squared gives us the rest of it. So if it was just x squared, it'd be a parabola. If it's just y squared, then we get a sideways parabola or a square root. Okay, so write these down because we're going to start with just hopping straight into graphing some circles. We're going to graph 2 circles, so you're going to need 2 graphs. There should be some on the table still. But if not, we're doing 2. So if you're looking at numbers, just 2 of them. I know, this table in particular, I don't know which period it is, but this table in particular just does not close the glue sticks. Because some of my classes are gremlins.
What's wrong with children?
I do believe you answered your own question. Children. They're children. When my Algebra 2 gets a hold of them, we get confetti. All right. They are safety scissors because you know what? Some of these classes I only trust with safety scissors. This is our first circle we're going to graph. Alrighty, guys. I don't know if I have any lefties, but I'm pretty sure I do have a couple of universals. So I do maintain awareness of the necessity.
If she
My mom is a lefty, so I do maintain the awareness of the necessity for dual-handedness. All right, this is the circle we're graphing. So we're going to find our center. Our center, remember that's our H and our K. So where is our center going to be? Check your formula. 3 and 1. X minus H, Y minus K. Catch the signs. What is our radius? 4. It's r squared on the end. We almost never will write it as 4 squared for you. You're going to have to know that. So our center is at 3, 1. And our radius is 4, so we go out 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you go out your 4 units in the 4 directions, like north, south, east, west, it's a lot easier to eyeball it. Again, not an artiste. Hush. Hush. I am not an artiste. Y'all just wait until I ever got to actually draw a thing. A thing. I've had, like, when we do quadratics and stuff, I usually draw a dolphin jumping over stuff. Ooh, it's bad. In fact, I will show y'all my dolphin. When we do quadratics.
No, but I did that yesterday. No. I ran out of resources.
That's my dolphin.
Such a big circle at the start. I thought you were
No, that's how we do a dolphin that jumps out of the water and lands. Yeah, that's my dolphin. I am good at art. My children know to come to me for math help and my husband for anything art help. My husband has a fine art degree. I am not good at art. Arting is not my thing. I can't even draw a straight line without a ruler.
I don't know anybody that can, though.
Some people can. But that's what we're doing for these circles. Ta-da, we graphed it. For now. Give me a couple of slides. Let's go kick up a notch. I mean, it's going to make the homework real hard if we don't at least talk about it. Homework questions are already picked, y'all. Just saying. Unfortunately, IU does not allow for Jungle Book final replacement swaps. Yes, dear.
So we have the radius by 16, right?
Yes.
And why are they?
Because it's x minus h, x minus k. So the formula, it's got a minus sign here.
Oh, okay.
Yeah.
Thank you.
Okay? Same process. Graph number 2. New graph, new equation. Same vibe. Where's our center? Zero, -3. What's our radius? It's 3. So our center is at 0, -3. I have a radius of 3. X minus what gives us x squared? X minus nothing. If there's nothing there, what's the mathy word for nothing? 0. That one's less bad for me. Mine is less bad. Significantly more circular. circulish. It's less bad. I will never judge your art. The mathematics of it I can see even if our art is bad. Do not connect them with straight lines and corners and we're good. As long as your circle doesn't wind up with corners, I'm glad. Okay? If you connect them up like this, then we got a problem. Do not give me a square. As long as it's circulish, we're okay. Okay? Any more graphs? Yeah. Because when we give you equations in this kind of form, we're ready to rock and roll, right? They're not always going to look like this. Okay.
Are we gonna need more graphs?
No, we're not going to have any more graphs. Because now we see what they're supposed to look like. Now we know what our equations are supposed to look like. But what happens when we give you an equation that looks something like this? This is going to be our first one that we play with. What happens when we have something that looks like that?
You gotta solve it.
Cry is not going to be the right answer. Unfortunately. I mean, cry can be the first step, but it can't be the last step. If we need the emotional release, I get it.
I give the answer and then I cry.
Okay, that's also a fine choice. Sometimes we need the catharsis, and that's okay. As long as cry is not your final answer. What we're going to do is we're going to bring back some completing the square. I'm going to put a whole lot of words on the screen. Do not panic. I know.
We gotta write all that?
I mean, it's steps. You don't have to write every word. I'm not going to come around to your notebook and say, you didn't put the and there. Is your notebook. All this is the instructions for completing the square, because we're going to put our x's together and complete the square. We're going to put our y's together and complete the square. That's the vibe. I will never, ever judge your spelling. Never, ever, ever. Okay? So what we do is we are setting the equation equal to 0. Our little one that I scared us with on the board over there is set equal to 0, so step 1's even already done for us. We're going to put our x's together. We're going to put our y's together. We're going to complete the square for both, making sure we keep both sides equal, and write it as perfect squared form. This looks like a whole lot of steps. If you remember how to complete the square, this isn't going to be awful. That is if we remember how to complete the square. Okay? Ready?
No.
Give you another minute or two. Remember, I do always post a PDF of the notes.
Oh my God, yeah.
Every day. Every day. Okay. So I'm going to put up, this is the next one on the slide. It's the exact same one that I wrote on the board to scare you. Okay? It's the exact same one. We are going to find the center and the radius of this circle. We know it's a circle because it has an x squared and a y squared. That's how we know it's a circle. So our step 1 was to set the equation equal to 0. It already is. We are good to go. So what we're going to do next is we're going to group together our x terms and our y terms. Oops, that's not what I meant to do. So I'm going to reorder this because it genuinely does not matter what order we add and subtract things in. So I'm going to put my 3x squared minus 12x plus 3y squared plus 18y equals 0. Just reordering. We are going to put parentheses around my x's and around my y's like this. Out of each of those pairs, I pull whatever the coefficient on my x squared is out. And we're going to put it in front like it's a GCF. I mean, it is, but... So it's going to be 3x squared minus 4x. Leave the x's in there. Do not pull the whole x out. We're just trying to get the number in front of our variable squared out. 3y squared plus 6y. Okay. I'm going to change my view screen just a second real quick. For this piece right here, what would we need to add in to make this a completed square? It'd be x squared minus 4x plus what?
No.
4.
Just add numbers.
As long as we do what? Add it to both sides. So on the other side of my equal sign, we need to add what? Yes. Because this 4 still has this times 3 in front. So over here, on my side with the 0, we are adding the 3 times that 4.
Why did you add the 4 in the first place?
So that we can put this as x squared minus 2 quantity squared. We're making this a perfect square trinomial.
Wait, why did you do the 3?
Because this 3 out front is still there. We added 4 inside here, but there's 3 of these.
But it was already, we didn't add anything to the 3. The 3 was already there, so why are you adding?
Because
Add
it's,
it in the equation and then.
I'll say thank you. Let me.
Oh my God.
Because it's 3 times this whole chunk. If I've added if I've added that 4 inside the chunk, there's 3 of those chunks elsewhere. So there's 3 of them. So we have to include 3 of the 4s because I added it into all 3 sets. Scott. All right. We do the same thing with the y. So if I come into just this chunk, y squared plus 6y plus what makes it a perfect square? 9. So on my other side of the equal sign, what do we need to add? I'm going to go put 3 times 9 because I feel like all of us saw that, but we were overthinking that particular math. Because I heard 18, 27, and 49, I think. Which, not entirely sure how we even got that one. I heard a whole lot of choices there. Okay. So that was steps 4 and 5 on that list that we wrote. Then we're going to come in and rewrite these all as perfect square, as like products, perfect squares. Because we already said we can write this as 3 times x minus 2 squared, right? Plus 3 times y plus 3 squared. See that? 39. I really don't like these 3's in front though. What can I do to get rid of those 3's? Divide them. I can divide everybody by 3. This 3 cancels, this 3 cancels. And so our equation is x minus 2 squared plus y plus 3 squared equals 13. And we have it in an equation that we can now use to answer the question. Because we haven't answered the question yet. What's the center? 2, negative 3. What is the radius? Radical form's fine. Square root of 13.
So how would we graph it? Or would you not ask us?
I would ask you to graph one like that. The closest we would come would be, I know that perfect square smaller than 13 is 9. Perfect square bigger than 13 is 16. So what's somewhere between 3 and 4?
Okay.
3.5-ish would be our radius. But I'm not going to ask you to graph one like that. Super
I
gross.
still don't understand how you add those numbers, like you added 4 and 9.
We wanted them to look like this. I need them to look like this in order to be able to find the center of the circle. So we took this and I'm like, what piece do we need to make it be a perfect square? I need this to be this. So if I add 4 inside, I can factor it down to be this. This was a factoring step in between. And this was factored. I needed to know what needed to be added in to make it factor down to a perfect square.
So are we always gonna use with equations that look like that?
Uh-huh. Okay.
Yes, this is F-E-L-E. I tried it.
All right. Let's do another one. Same vibe. Same vibe. We've got 2x squared plus 2y squared minus 12x plus 4y minus 15. Oh my gosh. I know I'm the worst. It's okay. I'm so shook up. Nope. Full page. Okay. So I'm going to rearrange stuff. I want my 2x squared next to my minus 12x. I want my 2y squared next to my 4y. And I want that 15 to cross the equal sign. So we're going to equal this to positive 15. Because I add 15 to both sides. All right? Break them up into groups of x's and y's. We're going to pull out from the x squareds, or from the x's, a 2. Leaving us with x squared minus 6x. This time I'm just going to leave a space so that I don't have to rewrite everything a whole another time. Same thing on the y's. We're going to take out that 2. Y squared plus 2y If it helps, we can think back to our complete the square days and when we did b over 2 squared, if that helps you for these middle terms. So this one, for our x's, we're going to add what? 9. For my y's, we're going to add what?
1.
b over 2 squared. 2 over 2 gives us 1. 1 squared is 1. So what we add to the other side, we add our 2 times 9 and the 2 times 1. So I'm going to rewrite this as our perfect square and simplify the right-hand side. So we have 2. What's this one as a perfect square? X what? X minus 3 squared plus 2. What are the y's? Y plus 1 squared. And it all equals to 35. I still don't like those 2's. Ew. Divide by what? By 2. Divide each term by 2. If I divide each term by 2, those 2's cancel. These 2's cancel. Who's breaking my stuff?
You broke it? That's crazy.
The surge protector?
Dang.
No, it's not broke. It's not broken.
It's probably just turned off.
It's working. I'm literally.
Okay.
I know what they're talking about.
They just trying to get you in trouble?
Unless you was checking.
I'm so shocked that they're trying to get you in trouble. Oh my gosh. No idea that you guys will be sarcastic ever. Oh my god. All right, x minus 3 squared, y plus 1 squared equals, yeah, that's fine, or we can leave it as 35 over 2. You can put it down into 17 and a half, but that's a choice. So, what is our center? 3, -1. What is our radius? Square root of 35 over 2. Minor problem with that. Square root in the denominator. Thinking too hard. But same vibe, but you're thinking too hard about it because we don't have any adding or subtracting down there. How can I make my denominator be not a square root? Because this is square root of 35 over square root of 2, right? What do we need to times it by? Square root of 2. Sorry, giving us more space, and I'll make it so it's not super tiny. There we go. So square root of 35 times square root of 2 gives us what? Square root of 70 over 2. Okay.
If we stopped at the 35 over 2, would that be points?
Like half or 1. Usually these would be lots and lots of points, so it would not be like, wrong, no points for you. No points for you. It would be just a little bit, because it almost always says in the directions that we get from IU that it has to be rationalized. Huh?
I don't see how that's fair.
It's because mathematicians be crazy. How about that? What's up? No. I am not going to ask you to graph a radius of this. Ew. 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 Super gross. The next test is the day before fall break. Just because I heard that question pop up.
When is fall break?
October 6th is the test. Okay? We're not done. Bro. Okay, so we're going to practice this a smidge. This way, and then we have one more tiny piece in this chapter after this. So we're writing an equation that has a center like this and a radius of 5. Center of 2, negative 3. So it's going to be what? X minus 2 squared plus what? Yep. Y plus 3 squared equals 25. Okay. This kicks it up a notch. Because now they're not telling us our radius, but they're giving us a point down the outside circle. How could we find out how far away that is? How far is it from the center to that point? The distance formula. So we're going to use that distance formula. Square root of 3 minus negative 2 squared plus 4 minus 1 squared. This guy's making a comeback. Like, we still not even done adding stuff in this chapter, just saying, by the way. Or in this lesson. Square root of 5 squared plus 3 squared. $25 plus 9. What's our radius? Oh, was it? Did I do it wrong? 25 plus, 34. Sorry. I'm math wrong in my head. Our radius is the square root of 34. So when we write our equation, x minus what? Or x plus 2 squared plus y minus 1 squared equals, what's our radius squared? Okay. Good, because we still got more. Okay.
Can you give me a second?
Yep, going back. Because they're going to give us a word we haven't heard in a while. Tangent. Not the operation tangent, the description tangent. So, if I have a graph and we are looking for something with a center at negative 3, 6, and it is tangent to my y-axis. What that means, tangent is very much how I feel like y'all will be in the car as siblings. I'm not touching you, but as close as we can possibly get. I feel like you two would play that game on a road trip.
What?
I'm not touching you. No, I know they're not, but I feel like just in totally play that game.
I'm nothing with it.
It means it's gonna
Oh, don't
touch
touch
the
me,
y-axis, but it's not gonna cross it.
I want to play this game.
Like that.
Wait, what?
Tangent means it's as close as it can get. It's not crossing it, but it is touching it.
Oh.
So, I'm just gonna do it up here for all of my, friends that are gonna watch this later because I went to the college fair. This one. This is my only dual credit pre-cal, so it's this one every single time. Yep.
Hold on, you said touching but not crossing?
Touching but not crossing. So it's gonna have like this. So what's our radius? That is so not centered, but that's okay. What's our radius? 3. Because it's 3 steps away. Okay? So it sounds super duper fancy.
Do we have to graph it?
It'll be 4.
No, but a sketch sometimes helps us see it.
It'll be 4.
But we're not going to graph it. We're just finding the equation. The graphing was really to help us kind of remember what's going on here. So what's our equation? It's touching, not through. Or like really, really close. Is not through.
What's the one that does? There were like 2 types.
So tangent hits it once. Intersecting would be going through. So what's our y's?
Y minus 6.
Y minus 6 squared equals 9.
9:41. Time to go.
This is probably our last one from today because it's a very similar vibe. Tangent to both axes, center in quadrant 2, radius 4. Which one's quadrant 2? Up left, right? So my center's somewhere over here. 1, 2, 3, 4. Remember? Okay, quadrant 2. Radius of 4. So it means here, and that's not even close to straight. There are both 4 because it is tangent to both axes. So what is our center? What's our radius? 4. So what's our equation?
X plus 4 squared times y minus 4 squared. And that equals
16. Okay. So we are going to have homework 2 due Tuesday because we still have another piece to add. Because we're not always going to deal with whole circles. Sometimes we're going to do semicircles.
Wait,
3.2 is going to be due Tuesday because on Monday we're going to need to talk about a smidge more because we've got semicircles. We are going to be here Monday. So just because y'all complain if I don't put it up there, there's 3-2. It is. It's a lot.
Yeah, no quizzes.
We will have a... Look at the yellow paper. It has all of them. It has the homeworks. It has the quizzes. It has the tests. Grab a yellow paper if you lost yours. I made like 15 extras because of that.